All right, so recall that the radical symbol is used to indicate roots. The index is a small number to the left of the radical symbol that tells which root to take. For example, this little 3 right here, this is the radical symbol, right? And that little number to the left of the radical symbol, that's called the index, that's 3. And that represents a cubic root. So, if we know that 2 to the third is the same thing as 2 times 2 times 2, which we know is 8, then if we take the cube root of 8, that would equal 2. And let me show you why. So a cube root cancels out cube numbers. So we know 8, right, is the same thing as 2 cubed, right? 8 is the same thing. And this index and that cube number, they cancel each other out. Like, I don't know, have you guys ever played that game like Fruit Ninja? I always like, it makes me feel good because I feel like I'm canceling out like the Fruit Ninja. They go away, they cancel each other out. So this cancels out cube numbers, it cancels out, and what we're left with is just this 2 right here. And so that's the answer, okay? So if we had another one, like the cube root of, what, 27, well, cube roots cancel out cube numbers. So is 27 a cube number? We just practiced that. Yes, it is. 27 is the same thing as 3 cubed, right? And what happens? This cube root cancels out that cube number, and what we're left with is 3, which is the answer. Okay? Now, just a helpful hint, okay, some things to remember. When b is equal to 0, no matter what that index is, the square root, cube root, it's always going to be 0. So this means that the cube root of 0 equals 0, the square root of 0 equals 0, the fourth root of 0 equals 0. If you wanted to take the 100th root of 0, guess what the answer is? 0, okay? And then the same thing is true about 1. So if you take the square root of 1, the answer is 1. If you take the cube root of 1, the answer is 1. If you take the fourth root of 1, the answer is 1. If you take the 100th root of 1, guess what the answer is? Yes, it is 1. So those are just some special examples that you need to know. All right. So let's look at this before we get started with example 1. So this is the definition of b to the 1 over nth. Okay, so this is a rational exponent. This is that fraction in the exponent which this whole section is about. So what it says is a number raised to the power of 1 over n, and that n can represent any number. So it could be 1/2, 1/3, 1/4, 1/5. They just have an n, so it represents all those different fractional numbers, is equal to the nth root of that number. So look, if we had 3 to the 1/2 power, a square root or a radical sign, it's like there is, it's almost like, you know, when you have like 1x, nobody writes 1x, you just write x, right? We know that it's 1 times x. Or if you had x to the first power, nobody writes x to the first power, we just write it as x. That's the same thing with a square root. A square root, we know that there's a 2 there, it's understood, but nobody writes that. We just write it as the square root of 3. Square roots cancel out squared numbers, okay? So all of these squared numbers that we previously talked about in one of our last, square roots cancel out all these squared numbers. So if you know that your number is a squared number, then you know that it's going to be able to be canceled out by those, okay? Okay. And then we have 5 to the 1/4 power. So this number on the bottom here, this 2, that represents what's going to go on the index. It just so happens with a square root, you never write it. It's understood with a square root that it cancels out squared numbers. But anything else, like if it's 5 to the 1/4 power, that 4 is the index there, okay? So this cancels out numbers that are written to the 4th power. This one right here, 2 to the 1/7, that 7th becomes the index in that radical symbol, okay? So that would be what's the 7th root of 2, and it cancels out numbers to the 7th power. Here's just a little bit. It says if b is greater than 1 and n is an integer, remember n being an integer is like whole numbers that are positive and negative, like -3, -2, -1, 0, 1, 2, 3, etc. Those are all integers. So if b is greater than 1 and n is an integer where n is greater than or equal to 2, then b to the 1 over n equals n to the square root of b. Yeah, we just kind of talked about that right here. This is just saying in algebraic terms, but I think you guys understand this. So let's look at some examples. Example 1. Okay, so we know that 343 to the 1/3 power, this is the same thing as, right? This is our index, so this is the same thing as the cube root of 343. So this cancels out numbers that are cube numbers. Now the question is 343 a cube number? We just did all those cube numbers, didn't we? Do you guys remember? Is 343? 343 looks familiar to me. It looks like it might be. Oh, and look at here, right? 343 is the same thing as 7 cubed. So instead of writing 343, I can write this as 7 cubed, right? And that cube root and that cube cancel each other out, and we're left with 7, which is the answer. All right? Perfect. Let's go ahead and look at this one. This is 32 to the 1/5 power. So that number on the bottom, that is the index, right? So it's the 5th root of 32 plus, this is the square root of 9, right? That's the index here, but we don't write the 2. Every other number we write except that 2. So this cancels out, the 5th root cancels out numbers to the 5th power. Is 32 a number that can be written to the 5th power? What do you think? Yes, 32 is the same thing as 2 to the 5th power. So do you see how easy this can be if you memorize the number? You just recognize, oh yeah, 32 is the same thing as 2 to the 5th, and this is the 5th root, and those cancel each other out right there, okay? And then is 9, so this is a squared root, which means it cancels out squared numbers. Is 9 a squared number? Yes, it is. 9 is the same thing as 3 squared. So this square root and that squared cancel each other out, and so what we're left with is 2 plus 3, which is equal to 5, which is the answer. All right, perfect. So now what I want you to do is I want you to check it out for example 1A and 1B. Here's my friend the pause dragon. Remind you to pause your device. Go ahead and work those out. When you get done, press play and we'll talk about it. Okay, so we are back. We know 81 to the 4th power, that's the index, so I can rewrite this as the 4th root of 81. Now what I'm asking myself is 81 a number that can be written to the 4th power? Here's all my numbers that can be written to the 4th power, and yes, 81 is the same thing as 3 to the 4th. So I can write this as 3 to the 4th, and then what happens? This 4th root and that 4 cancel each other out, and we're just left with 3, which is the answer. If you got that one right, great job. Okay, let's look at this one. 121 to the 1/2 power plus 256 to the 1/4 power. Ooh, so this is can be written as the square root of 121 plus, this is written as 56 to the 4th root. Can 121 be written as a squared number? The answer is yes. 121 is the same thing as 11 squared. What about 256? Can that be written to the 4th power? That number looks really familiar. And yes, 4 to the 4th power is the same thing as 256. So I can write 4 to the 4th, and then what happens? This square root cancels out with that squared. Boom shakalaka, I'm left with 11. And this 4th root cancels out with that number to raise to the 4th power, and I'm left with 4, and then it's just 11 plus 4, which is 15. So if you got that one right, Yokaninki Meshal, you did a wonderful job, and I'll see you in a little bit for example 2.